Hello, beautiful people on YouTube. I am Mark John, and I built something that is kind of cool and wanted to show you. So this is a project I built for CS 128 Honors. This is a Rust tic-tac-toe server. So it's a simple multiplayer game server written in Rust for the game tic-tac-toe. Now let's see how it works. Here we have 3 terminals, and on the left, I will start the server. And in the middle, I will start a client. And I'll do the same for the right panel. Now I just need to type join server for both rooms. I'll do Mark for this one. And let's do Valley, my roommate, for this one. Okay, now my roommate and I want to play a tic-tac-toe game over the internet. So what we do is we join the server, and he's going to create a room by typing create a room. Let's go with ABC. And once he has created the room, because there's only one player in the game, the server will tell the client that it's still waiting for players. So now I can join the game. I'm in join the room, and I'll do, let's see, ABCD, and it will say, okay, room does not exist. And then I'll know, okay, probably made a typo. Let's try it again, join ABC. Now we have, now I joined the room, and on both our screens, we can see that we're looking at the same board, and we can start playing the game. Now, because Valley first joined the game, created the room, it's his turn to play. So we'll just do a very simple game tic-tac-toe. We'll make this really fast. So place at 1-1. Okay, Mark's turn, my turn. Place at 0-1. Okay, Valley's turn. Place at, let's say 2-2. Okay, place at because I'm dumb, I'll place at 0-2. And now Valley sees that, okay, he has a chance to win. So place at 0-0. And it says Valley has won on my panel, and it says you won on Valley's panel. Yay, it works. So Valley thinks the game is pretty cool. He wants to restart. So he typed restart to, reset the game. It says Valley's turn again, but I don't like losing, and I feel really stupid about it. So what I'm gonna do is I'm gonna rage quit. So I'm just gonna type leave server, and it says connection closed. So I left the server, and on the left you can see the server's log that client Mark has dropped from room ABC and has done all the cleanup. And on the right hand side we have Valley's panel, and he's just waiting for players because I dropped from the room. So he decided to leave room again, and then leave server. And on the left, from the server log, you can see that there are no more clients and no more rooms in the game server. And that's pretty much it. You can there are also some details that I won't talk about within my room joining, like exception handling and all that stuff. Those are really minor details. If you want to see how this works in details, or if you just want to try it, just go to the GitHub. I'll link below, and then you can start the project and run it for yourself. Okay, so let's talk about some of the details within this project, and how I built it and the libraries I've used. The first thing I want to talk about is this game server is built on Lunatic, which is a relatively new runtime for server-side applications. And basically, it organizes your code. It uses an actor concurrency model and works still in asynchronous executor, so that you can run your code in a way that is easy for you to do parallel programming, and then very easy to reason about, and it's also very scalable and fast. And because this is a relatively new that's not what I want. One moment. And let's just go into our code and see what's going on here. Because we're using what's called an actor currency model, you have heard about it. Basically, it's organizing your code into different processes. You have different processes that will handle different stuff, and they will communicate with other processes using message passing, sending messages to other processes mailbox. So in my case specifically, every TCP connection is handled by its own process within Lunatic. So if one process died for whatever reason, it won't crash the entire server. And also because everything on the server side is compiled to WebAssembly, if you made something that's pretty bad, I mean, this is Rust, you can't like have sig faults or anything, but if you happen to integrate this with some of your C++ code, then because of the WebAssembly sandboxing, it won't be able to crash your entire server. So that's very good. And the second thing I want to talk about is how the client communicates with the server. Instead of a naive way to go about like updating the state of the client, basically syncing up the state, is to send out the state every single time something has changed. However, I wanted to make this as efficient as possible, so I use a library called DPA that handles object deltaing. Basically, if something changed, only the change will be sent over the through the TCP connection to the client. So we try to keep the data sent over the network as minimum as possible. And then I used Beancode and Third for serializing and deserializing. Those libraries made things very easy. And something I'm very proud of is separating the game logic and the state. If we just go into main.rs in the server, you can see that I have a game room struct, and here is basically pretty much all the game logic, the server logic. You just need to implement the game room trait and implement these callbacks, and then you can just pass this object into the library, and then it is able to basically handle all the room creation, joining, username or server name, duplication, error handling stuffs for you. So as you can see here, for example, on message, callback is called when a new message is received from a client. So this is really simple. So basically, client only have two actions within the game: place node and restart. So you can just handle these messages, and then at the end of the function call, you just need to call contact.broadcast the state, and then the state will be either the state or the delta of the state will be broadcast to the client. And this is all handled within this library that I've written. Now, this is pretty much all the interesting stuff on the server side, but you can check out the code if you want. And on the client side, I use Tokyo for asynchronous programming so that I can receive messages whenever they are sent over to the client, even when I'm typing. So, and that's for the client. Okay, for future, I want to continue to develop this code base because I can see this becoming its own universal, very generic multiplayer game server library, because I've already separated out the logic of the game and the server. So there are several more things I want to handle, and then do better error handling when different things happen, and do some bug fixes. But this has been a very fun project for me, and I've been working on this pretty much for the whole Thanksgiving break. And Rust is a lot of fun. I love it. I love Rust. And if you think this project is interesting, give it a try. Once again, the code is on my GitHub. So have fun coding and have fun exploring my code. All right. Have a very good day, everyone. Remember to like and subscribe. How do I stop?